joint break.
Yeah, so this is actually joint work with Duncan. So one of the motivations I have is because Duncan was calling out for more people to help him, right? So I think he has been doing great work on Cabal. We are all using it, even though we are all complaining about it. We are still also very much relying on it. It has made our life so much easier. So I'm actually willing to, like, if you have any complaints about Cabal, you can also send them to me from now on. If you have positive things to say about Cabal, continue sending them to Duncan.
Send it to everybody.
Or even better, send them to everybody. So, this is about writing a new dependency solver. Why? Why are we doing this? So, actually, it's more an evolution than a revolution. So the main reason, I think, is that the original solver was just written to do the job without really thinking very much ahead. And it actually did the job relatively well, but by now we know quite a bit more, and we see where the old one is going wrong and where we would like to extend it. And there are a couple of issues that are particularly clear that they are not optimal, and one is error messages. So actually I could probably make a far more entertaining talk by just spending 10 minutes now just showing Cabal error messages.
Yes, yeah.
We'll see a little bit of this later demo, but not now. And the other issue is that there are certain things that we would like to tweak or experiment with or extend in the solver. And at least to me, as an outsider who has been looking at the code and staring, I found it's not so easy to make these changes. Perhaps that's just a general thing, rewrite easier than extension, but I think it's actually the new one is hopefully. So, all right. So, why have we started on this now? That's actually because, well, we started at the suggestion of the industrial Haskell group, where we were doing some work for, and there was a particular trigger, namely that there was a suggestion to add support for private dependencies to the cabal-install solver, and it turned out that that was an extension that wasn't easily doable within the old one. And ironically, I can say that already, the new solver is there, and these are still not implemented. But there is a plan to support them. So what's the status? I'll say this right now. There is a new solver. You can use it right now. I think after testing it for quite some bit, I think it's at least as good as the old solver, at least if you're working with GHC7. There is a tiny little thing about the library configurations that GHC 612 used, namely that base 3 was wrapping base 4, which I've not got around to implement in the new one. So for GHC 6, I wouldn't recommend it, but for GHC 7, you can basically just plug it in. And it's a branch, and I'll show the URI in the end. You can experiment with it, you can look at it, you can play with it, you can send bug reports, you can send feature requests, whatever you like. And there are a couple of features which are not yet implemented, but we have a plan for what to do. So I'm going to briefly explain why or what dependencies in Cabal are and what we have to consider. I'm going to show how the new solver is implemented. I'm briefly mentioning this private dependencies thing. I'm talking about error messages here, and then there will be future work, lots of future work. So when you call cabal-install on the command line, there's actually quite a number of things that are happening. And the first things roughly that are happening is that Cabal starts reading the package index usually and the installed package index from GHC. So in order to gain information about what kind of packages you actually have on your system. And then you invoke the solver to work with this information about which packages you have and the goals you specified on the command line, or the implicit goal that you just run cabal-install in some directory, in order to resolve the dependencies and come up with something that's called an install plan. And then there is a separate checking phase screen, or cabal-install actually starts executing the plan and installing packages. Okay, so we're basically only looking about at step 3 here, and the fact that we have an independent sanity check was actually very helpful during developing the new solver, because it means that it's relatively easy to trust the new solver. I mean, you definitely, if it would be doing things completely wrong, then the checker would complain, and you would not just get a broken system, but you would get a warning at an early stage. So a little bit of terminology. Everybody likes to call these things slightly differently, but I will try to stick at least to my own terminology for the rest of this talk. So index I'll call the stuff which contains information about packages. So both the install package database that GHC has and the remote package database that package has. Locations are the things like where the package databases actually are, right? Whether it's your installed one, or whether it's package, or whether it's another package server. Name packages themselves, they have names, they have versions, and actually if you combine the name, a version, and the location, you get something which I call an instance of a package. Like MTL version 1102, which is installed on your system, that would be an instance of it. Then
also the version on the package is also an instance.
That's a different instance.
It's a different instance.
Yes.
But nevertheless, it is an instance.
It is an instance.
Yes. Installed.
Yes, exactly. And then you get the restrictions on versions and locations, and those are called constraints. And if you have a constraint for a particular package name, then I call it a dependency. Okay, so a couple of issues just in loose order about what makes Cabal's dependency problem somewhat special. So first of all, there are flags, lots of flags in the packages that actually influence the dependencies. And they're actually rather flexible, so they can be rather deep nested decision trees that can say, oh, if this happens, then include these dependencies, and can go deep down and multiple choices several times and so on. So that makes it all a little bit trickier. And then one of the main issues is that actually it's not enough to know a version and a name of a package to uniquely identify it, but we actually have to consider the transitive dependency closure, right? I mean, whenever you even have somewhere deep down in the chain a certain package and you would change that version, it might in general be the case that there are certain things that are passed all the way through up into the interface of the upper package, so that the interface changes. So in general, we have to be very careful about identifying installed packages. So in particular, that means that we have to keep track, and GHC does that, about dependencies of all the installed instances, and they all have fixed dependencies on very particular other instances that are on the system. Whereas if you have new instances that are residing on a package, they usually have flexible dependencies, right? So they say something like, I depend on an MTL between version 1 and 4, or something of that sort. And in general, we have the situation, as I just explained already, that if you have a single application, that we have to be pessimistic, and that we cannot use multiple instances of the same package within a single program, because in general the problem arises when type information sort of leaks from two instances of the same package, that would be impossible to configure on the system anyway, so that already in the latest version of Cabal solves quite a bit of installation problems that you might have been getting earlier. Currently in the old one, flag resolution is sort of tied to package selection. So whenever you make a choice for a particular instance of a particular package, you also sort of need to resolve all the flags at the same time. And that's perhaps sometimes not so useful. And for the error message problem, one thing to observe is that there's hardly any information maintained about in which order the packages are selected and what's going on, why and where. So let's look at one of the main problems that we can have with Cabal. So Cabal can actually break your system, and probably most of you have observed this once or twice, but perhaps many of you aren't actually aware what's happening. So I think it's perhaps valuable to once walk through that scenario, because already being aware of it can make things quite a bit better when they actually go wrong. So if you have a situation that you have a package and a particular instance of a package residing on package which is called B1, and that has a dependency on any version of package A, and then you install it on your system. So when you install it on your system, there's obviously a particular version of A being picked, and the dependency is fixed. So you get an installed instance where B1 is depending on A1. And later you go on and install lots of other stuff on your system which might depend on B1, right? So you install a package C1 and lots of other packages that use these packages here that you already have. So that's all fine so far. And now you are going to install a strange package from package recently released by one of the very productive package authors, and that's D1. But that uses the latest and greatest features and doesn't work with A1 anymore, but needs A2. But it also still depends on B. And B, we know from the past that B actually depends on A. So now, if you look at what Cabal install sees, it looks at this system and sees, oh, well, B1 depends on A2, so there's no choice here, and B1 depends on A, but I've already selected an instance for A, and within one program I should only use one instance of A. So it will say, okay, so B1 also has to use A2. Right? And now this thing is installed onto your system, and the restriction of the GHC package manager to have only one instance per package version kicks in, and you get a destructive update from the old B1 that depended on A1 to the new B1 that depends on A2. And at the same time, all the stuff that previously depended on B1 on your system breaks. Right. So that's the single most frequent reason for breaking your system using cabal-install, and it happens because you have these destructive updates in there. And now, of course, how would you solve this? The proper solution, I think, is relatively clear, since we already have a system that works with hashes, and we basically have all the situation, the information there. The best way to solve this would be to move to a NixOS-style package database, basically saying you can have arbitrary instances of packages installed at the same time. There's no restriction whatsoever, and you never ever remove something that has been installed into your package database, except if you do some form of garbage collection, thereby taking a global view on the whole database and making sure that you don't break anything. There are some other options that we can do on the short term in order to prevent this problem at least slightly, so we can make Cabal much more informative about that this situation is going to arise, because actually Cabal knows this before it starts installing stuff. It can exactly see that there are destructive updates are going to happen, and it should actually warn you in the letters that you're about to potentially break your system now, and do you really want this? And you can also configure your solver to actually, the dependency solver, to actually try very hard to find solutions that don't perform on destructive updates. Okay, so
you didn't say why, so just to top the solution. the solution?
Um,
Or why mess about with that one?
how it works?
Oh, is it?
I think it's not so completely trivial, but I mean, I'm willing to learn it is, and then we can just ship it.
So is this an orthogonal question to what you're about to talk about in the solver?
Yes.
Okay, good.
I mean, nothing that we are doing currently prevents this from being implemented.
Okay, but you solvers still need it.
Yeah, well, I hope so.
Okay.
So I'm very much interested in this to happen sooner or later, independently of any solver questions.
Sorry, actually I got confused about one thing. So if we did with Nixon, wouldn't we then have a problem? Wouldn't we then run into the constraint that we can't have two different instances compiled in the same package? Because we would try to use
Same application, you mean?
yeah, like if I try to build
that constraint is still there. That constraint is still there.
okay.
So that constraint in itself doesn't require any destructive updates on your system, and it may prevent you from actually installing something, but it will not ever break something that you had already installed on your
So
system.
we go back to your diagrams.
Yes.
The one with B. Is easy enough, isn't it? So it's, well, we just install
Sure.
a different instance of
Yeah,
B.
sure. You just leave
Right,
the
but
picture
now-
of this,
but now if I try to
rather than doing this extra step, which is
but now if I try to install something, if I try to compile my program using C1 and D1, it refuses to compile, right?
Yes,
C1.
yes.
Do you
Yeah.
need more
Because it cannot have both of the B1s.
No, then it'll just add an extra, it'll recompile, you'll get an extra instance to C1 built against B1. You haven't dealt with it there.
So it'll rebuild a new C1.
A new
C1.
Okay. New
Yeah.
C1. All right. So it'll let us build.
Yes. I mean, that's like like a mixer as if you actually upgrade glibc, it rebuilds your entire system, you get 2 copies of all your packages on your system.
Sure.
They happily coexist.
But in a NixOS strategy, when do I get to the point where I cannot compile, where I cannot install? Did you ever run into that?
No, I mean, these questions are completely independent in a way. I mean, whether you manage to find a solution for your local install problem is sort of independent of the question of how do you manage all the stuff that you have installed at the same time on your system once it's there. So I think, yeah, perhaps it's misleading that I included this in the talk, but I think it's still it's a very important problem with the current system, even though it's not directly related to the solver. I think it's good to be aware of it. Okay, so what we're doing is our new algorithm sees the whole thing as a constraint satisfaction problem, where essentially you have to find an assignment from something like package names to package instances, and additionally from flag names to boolean. So you have a number of variables, and you have certain constraints on these, and you need to find an assignment that solves all the constraints. So we do this by building lazily an approximation of a search tree that gives us a representation of all the choices that we could make to derive potentially a solution. And this is an approximation because at first it actually contains all valid solutions, but it may contain incorrect solutions as well. And then we have the second phase where we validate the search tree, where we actually just remove all the stuff that is wrong, and the resulting tree actually should only contain valid solutions. And then we have several passes where we rearrange and optimize the search tree. So we actually throw away certain things that we definitely don't need, and we reorder certain stuff. And we that attribute the tree in a slightly different way. So for Lloyd, it's really just an attribute grammar in multiple phases. And in the final phase, we actually take the tree and produce an assignment and some dependency information together with lots of logging information. So it's all just building up, transforming, and traversing. The tree itself has a couple of different nodes, basically choices for packages, choices for flags, choices for goals. You can explicitly succeed and you can explicitly fail. And so packages are mapped to instances, flags are mapped to booleans, and choices are between open goals, and then you have lots of trees back in there.
You just take one of these and tell me how to read it.
Right, okay, so
P-choice.
P-choice takes something which is called a qualified package name, some extra additional information that you can freely choose, and it returns you a priority search queue of an instance, which is the one that you actually select. So you select for the package a particular instance paired with a subtree. Right, so basically the nodes are representing choices and variables, so to speak, constraint variables, and the edges are representing particular instances.
I just don't see any branching in this tree.
Oh, here. Multiple. PSQ is think of PSQ as a map or a list.
Oh, right. Well, I see lots of different eyes.
Yes. N-ary branching trees. Okay. I'm actually going to, I think, yeah, well, so we have goal choice nodes, which give some flexibility to the order which they are solved. We have package goals to pick instances from package flag goals to resolve flags, and they can actually appear in any order. And we have explicit success and explicit failure nodes. And we can always add additional nodes. And then, basically, we just build the tree by keeping track of the current goals and trying to figure out which ones we still have to add, and we don't get the constraints yet at all. We add always all choices that we have, and if we have no goals left, we end with a success node. And then in validation, we remove choices, but we basically just tag them as being disabled in order to produce better error messages so that we can still see that the choices are in there and that they just are removed. And then we have lots of reordering steps where we can swap the branches or the children of nodes in order to express preferences, because ultimately the exploration will be roughly left to right. So moving children more to the left means that we intend them to be well, preferred by the user. So I'm running out of time, so I'm actually going to give a demo before I don't have the time anymore to give a demo. So let's see. So if you see a lag, this is because this is a remote invocation. So let's try to say with the old cabal, let's try to do cabal-install dry run ESOL. And you can see here, I'm doing this on a relatively recent snapshot of GHC head, simply because that's a more interesting dependency problem. On GHC 704 by now, basically everything works on package, right? I mean, that's the main supported version. All package authors have made sure their stuff works. GHC head is actually a better chance to get packages that fail. So that resolves dependencies, and then you wait a while. finally, if you run the modular solver on it, you get something which is perhaps still hard to read because it's a lot of information, but I'm very interested in feedback on how to present this better. But I do think that it contains at least enough information. So what is it saying? You are trying to install Yesod and it picks the latest version, which is the user goal. Then it's trying to install HTTP types, which is a dependency of Yesod. Then it's trying to install case insensitive, which is a dependency of HTTP types. Then it's trying to install Unix compat, which is a dependency of Yesod. And then it's starting on work, which is also a dependency of Yesod. But now it's telling me that none of the versions of work. And for each of them, it's giving the reason. So for all of these versions, they don't work because we've already selected Unix compat 3, but work in these versions depends on Unix compat between 0 to less than 03. And similarly, these versions work for other reasons, or don't work for other reasons.
So the indentation or prefix might help.
Sure. I mean, there are some basic things like layout and everything that I'm sort of aware of myself, but I also still think it's a bit much. So smaller would be better, but I would really like constructive suggestions on what's the perfect error message you would like to see here. Still, I want to show that you can also enable like unbounded backtracking in the new one, and you can actually do this by setting the max spectrums to -1, and then it actually does find a solution, and it still doesn't take extremely long. So that's quite nice, and you can try a lot of other things. So I'm going to skip all the rest, invite you to look at the slides, and invite you to try the prototype, which you can get from here.
Well, okay, I have one question, and everyone is out to go for coffee, and you can question it during the break. So one question.
So just going back to think we were talking earlier about different instances of packages. If we made a change in GSC package so you could do this, because at the moment it's explicitly disallowed.
Yeah.
Not very technical reasons, just because we're talking about the confusing. If we allowed them, would the solver just work, or would you need to do extra things there too?
I think they're all functional, I think.
Yes, I think the solver wouldn't need to change at all, I think.
Ah, so it's really easy.
Okay, but there's still a package management problem when you do that, but it's totally functional solver.
Yeah, I think we should talk about it offline.
Yeah.
I think it might not be entirely trivial, but from the solver perspective, it should be, or from cabal-install's perspective, it should be relatively easy. From THC packages perspective, it might be not entirely easy.
Okay, so if anyone else has questions, come up and ask, but everyone else is allowed to, you are released to have fun.